This recording is to help you with lesson 5.02, verifying trig identities. And in class today, I gave out a sheet that has the identities all on there. And you can use that on your homework and your Unit 5 test and your final exam if you need it. Okay, let's start out here. In class I said that we always start with the left-hand side if we can. So looking at the left-hand side and the right-hand side, it looks like only sine appears on the right-hand side. So I'm going to try to rewrite cosine in terms of sine. And I know that cosine squared beta is the same thing as 1 minus sine squared beta. And these are just Greek letters, and they're using a whole bunch of different Greek letters instead of x. And that's okay to do so. If you prefer to use x, I mean, that's perfectly fine with me. We don't have to use all the different weird Greek letters here. Okay. Combining like terms, I get 1 minus 2 sine squared beta. And that is what we were trying to prove on the right-hand side. All right, here we're trying to prove that cosecant x minus sine x equals cosine x cotangent x. So again, let's start on the left-hand side. And I'm going to rewrite cosecant as 1 over sine minus sine x over 1. And I am going to get a common denominator. So I'll need to multiply by sine x on the second fraction. When I do that, I get 1 minus sine squared x all over sine x. I can replace the numerator with the Pythagorean identity. That's the same thing as cosine squared x. Remember, we either did this one or one similar to this in class today. Let's rewrite the numerator as cosine x over sine x times cosine x over 1. And I know cosine x over sine x is the same thing as cotangent x times cosine x. And because multiplication is commutative, we can rewrite that the other way around. And that is what we were trying to prove on the right-hand side. All right, using the cotangent identities there, or the cofunction ones, we know that cosine of pi over 2 minus x is the same thing as sine. I'm going to start by rewriting that. I know that cosecant can be written as 1 over sine. And when I multiply this, I get sine x over sine x, which is equal to 1. And that's what we were trying to prove or show. The next one here, kind of very similar. We have cosecant x. Cosine of pi over 2 minus x is the same thing as sine. I'm going to rewrite cosecant as 1 over sine x. And this one turns out to be almost identical to the last one, except the way we're multiplying. So sine x over sine x, again, is just 1. All right, this is a little bit more complicated. I'm going to look at the left-hand side. And what I'm going to try to do is I'm going to try to factor that. Now, I'm going to look at it as just with x's first. And I'm going to take the cosecant out of the picture. And I'm going to say, okay, is there a way I can factor that? And I'm going to say, well, x squared minus 1 times x squared minus 1 would get me that polynomial if I were to FOIL it. So now that that's factored, let's just add in the cosecant in front of it again. Okay, so there might be times where you need to factor. And I know that cosecant squared x minus 1 is actually a Pythagorean identity. And I know that is equivalent to cotangent squared x. All right, and I would add my exponent, so 2 plus 2 is 4. So I get cotangent to the 4th power of x. Now there's one very similar to this in your homework that has to deal with sine. So look to try to factor and then use your Pythagorean identities to help you rewrite the problem. All right, and then the last one, all right, we'll start with the left-hand side. And we have that negative out front. Remember, we can change the negative into a power, or any number really that's out front, into an exponent. So that's to the -1 power. Well, if I were to rewrite that, that's the same thing as saying 1 over 1 plus cosine theta. All right, we don't want to leave the cosine theta in the denominator, so we're going to multiply by its conjugate. Remember, the conjugate is 1 minus cosine theta. When I do that, I get natural log of 1 minus cosine theta in the numerator. And the middle terms drop out, and I'm left with 1 minus cosine squared theta in the denominator. Here you can use the Pythagorean identity. Remember, 1 minus cosine squared theta is the same thing as sine squared theta. Okay. Let's expand that now like we did in class today. We can expand division using subtraction. And we have a squared here. And let's bring that squared out front. So that is one of those natural log properties as well. So we have -2 natural log of sine theta. And I technically should probably make these into absolute value signs instead of just parentheses.